Unit 2. Here we go. Now we're going to do inductive reasoning and conjecture. So now we're starting where you have to explain. You have to understand. You have to be able to justify. Prove it, prove it, prove it type of thing. All right, so we're going to start off with making conjectures based on inductive reasoning, and we're going to find counterexamples. In other words, this is the reasoning why you need to show that you can prove things. We'll get to the proofing later. Okie dokie. So what is inductive reasoning? Inductive reasoning is reasoning that uses specific examples to arrive at a conclusion. Uses of, I don't know how that worded. Anyways, so the point is that you're using examples to help you arrive at a conclusion. Now, your conclusion or your concluding statement is called a conjecture. So when I ask for a conjecture, I'm looking for a concluding statement. So for the next few examples, I'm going to write a conjecture that describes the pattern in each sequence, or I'm going to want you to write a conjecture that describes the pattern in each sequence, then find the next item in the sequence. Okay, so here's one that's like, let's say, non-math, non-geometry, or whatever. Movie show times. Okay, so one starts at 8:30, and then another one starts at 9:45, next one 11 o'clock, and then 12:15. So, do you see a pattern? Okay, well, you can see a pattern that this goes from 1 hour and 15 minutes later. The next one will go 1 hour and 15 minutes later. And the next one goes 1 hour and 15 minutes later. So, what is your conjecture? Okay, I'm going to do the conjecture in a different color. So, the conjecture here is that show times start 1 hour and 15 minutes later, or as they put it in the book, the movie show times, the next one is always 1 hour and 15 minutes greater than the previous one. I would have said later, but they said greater. Okay. Anyways, so what does that mean? That also means that the next show time would be at 1:30. So you've got here that it starts, that your conjecture is what I wrote in green, and then the next number in the pattern, or the next thing in the pattern, would be 1:30 p.m. Alright, so here's the next one. Notice how I drew the little figures, like there's 4 little sections, kind of making a little square, then I extended that out, one each, and so that made 10, and then I had 18, and then I had 28, and then I had 40. This was not fun to draw, that's all I can say. Anyways, so what is the pattern? Okay, so if you see a pattern, first one goes from 4 to 10, so that's 6 more, then it was 8 more, then it was 10 more, then it was 12 more. Oh, do you see a pattern? It looks like it goes up by 2, so that means the next one would go up 14 more. Very good. So your conjecture would be that the next figure would have 14 segments added to it, so that way it would have 54 segments. And by the way, I'm not going to draw that, but I'll tell you what, if y'all draw it and show it to me, 5 points on the test. Okay? So, yes, it will have 54, will then have 54 segments. Boom. Okay, so these are conjectures. Remember, what you're writing in sentence form what you see as the pattern, and what's it going to do to the next one. Okay, so for the next examples, instead of giving you, say, some things to see the pattern, I'm going to give you what is the pattern, I guess you could say, or you got to, like, say, give yourself some examples, create some examples. So, here, statement. Sum of 2 odd numbers. That's it. Well, think of an odd number. 1 and 3. What does 1 and plus 3 equals? Because sum means add. 4. Okay, let's try another odd number. 1 and 5. I didn't say they had to be consecutive or anything like that. So they can repeat. 1 plus 5 is 6. And let's try 3 and 5. That's 8. 7 and 9. 16. Okay, I'm just picking odd numbers at random. Well, actually, I'm picking them from the book, but that's a whole different story. Anyways, so what do you see as a pattern? What's your conjecture? Well, if you notice here, 4, 6, and 8, and 16 are all even numbers. So it looks like when you add 2 odds, you get an even. So that could be your conjecture. The sum of 2 odd numbers is an even number, or is even, if you want to put that. Okay, so the idea is, again, you're putting in sentence form what you believe is like the statement, what you get from the information. Let's do one with another example. Okay, so this one is called, this one I say the relationship between AB and EF. What is the relationship? Basically, you're going to give me a conjecture about the relationship between AB and EF if AB is equal to CD and CD is equal to EF. So if you kind of draw this out, let's say we had AB, line segment AB, we have a line segment CD. It doesn't matter how they look, I'm just doing all sorts of different directions. And here's EF. Well, if AB and CD are equal, and then it says CD and EF are equal, then because these all have little hash marks, you can conclude that AB is equal to EF. This is actually something I believe is called the transitive property, but we'll hopefully see that later. Anyways, that we can conclude, that's our concluding statement. AB is equal to EF. Line segment AB is equal to line segment EF. Okay, so now you've got to be careful with what about a counterexample? To show a conjecture is true for all cases, what you're doing right now is just coming up with a conjecture. You are pretty sure it's true for all cases, but it had to be true for it to be true in all cases. For it to, like, no matter what example you could come up with, it has to be proven. You have to prove it. It only takes one false example, however, to show that a conjecture is not true. So that false example is called a counterexample. So sometimes, especially when you're doing inductive reasoning, the idea is to try to come up with a counterexample. For example. That's kind of weird to say that. Anyways, if n is a real number, then n squared is greater than n. In other words, if you pick any number, you square it, you're going to get a number that is bigger. Okay, well, you know, I can come up with examples. Like I could say 2 and 2 squared is greater than 2. I can say 3 and 3 squared is greater than 3. So I have to come up with a counterexample. Those are examples that prove the statement. So here you're trying to find a counterexample, one that doesn't prove the statement or proves it's false. Because this is supposed to be true all the time. Well, what about 1? When you square 1, is 1 squared greater than 1? No, because it's equal to 1. So that's a counterexample. It proved that it was false. Okay? Let's see here. Let's try from, oh, here's a good one. If JK equals KL, then K is a midpoint of JL. Okay, so if you kind of try to think of that, oh, let me think, I'm going to make a line, and I'm going to put J here, and I'm going to put L here, and I'm going to put K in the middle. And I'm going to say that they're both equal, so that's the midpoint. Well, that proves your example. But can you come up with a counterexample? Now, keep in mind here, let's put a J, let's put an L. Let's put JL. Does it say anywhere that K has to be on the line? No, it does not. Oh, and look, JK is equal to KL, but it is not the midpoint of JL. Counter example. Boo-yah. Anyways, we'll try to do some more of this later, or when I see y'all next time, and we'll even try to see how we can come up with some conjectures based off data, maybe using the calculator, if we have time. Anyways, that's it for today, guys. Thank you so much for your time. Y'all take care.